All right, here we go. Okay, the first thing I want to talk about is graphing a complex number. Okay, this is something that appeared very briefly in Algebra 2. Does anybody remember graphing complex numbers?
Those ones have like the bumps without the not on
Okay, we are going to graph it on a coordinate plane, but it is the complex plane where the horizontal axis is our real axis and our vertical axis is the imaginary axis. Okay? So whatever our real piece is will move horizontally, whatever our imaginary piece is will move vertically. So here you see this is the number 3 plus 4i. So we moved over 3 horizontally, and then we moved up 4 vertical. I'm going to have to take a quick time out here, guys. There we go. Okay. This number over here, negative 2 plus 3i, we moved left 2 on our real axis and then up 3 on our imaginary axis. Okay, and then here's the number negative 5i. We did not have a real piece to this, so we did not move horizontally, and we just moved down 5. Left. Just keep in mind this is the complex plane. Okay? It's not the real plane where we usually graph things. Okay? Okay. What is the definition of the absolute value of a number? The distance from 0. Are you guys okay with that definition? Yes. Okay. So, if we are talking about the absolute value of a complex number, when we graph a complex number, how do we figure out how far away from 0 it is? Same principle. Right. Okay? We're talking about basically the line segment back to the origin. Okay? So it's going to be similar to the magnitude of a vector, okay, because our point of reference is the origin. Okay, we want to know how far we are from the origin to our complex number on the complex plane. Okay, so we can think of this as the Pythagorean theorem. So the absolute value, distance from the origin, is this dotted segment right here. Okay? We can think of this as a little right triangle, right? So our absolute value is going to be the square root of 3 squared plus 4 squared. Okay, we don't need to worry about the I because we're just talking about our distance. Okay? And so the absolute value is what?
5.
5. Okay. So we need this concept for the absolute value, or not the absolute value, this is the absolute value, the trig form of our complex number. Okay? Alright. So I want to look at this picture right here. Okay, this is basically what we had drawn on the last slide that we used for our absolute value. Okay? How would we find that angle theta? Some trig. Okay? If we knew, okay, inverse tangent is b over a. Very good. If we knew what we knew, right? Okay. So, do you agree that a is the same thing as r cosine of theta?
Yes.
Right? Because the cosine of theta would be adjacent over hypotenuse, right? Okay. And you agree that b is r sine of theta, because the sine of theta would be opposite over hypotenuse. Okay? What does r represent in this picture? Okay, the absolute value, okay, which is represented by the distance back to the origin, right? Okay, so if I take a and b and I substitute it back into, we wrote that z equals x plus yi, okay, or a plus bi in this case. The trig form of a complex number looks like this. Our cosine theta is our real part, a. Our sine theta is our imaginary piece. Okay. What? Okay. Wonderful. Okay, so what we're going to do, we're just going to practice from going from one form to another. Can we take a complex number in standard form and put it into trigonometric form? And we take one in trigonometric form and put it in standard form. When I say standard form, what do I mean? A plus bi. Okay. All right, so here we go. Our complex number is -5 plus 6i. We want to put it in trigonometric form. Okay? So for trigonometric form, what do we need? We need the absolute value, which we represent with r, and we need the angle theta. Right? So I'm just going to make a quick sketch of -5 plus 6i. What quadrant does this lie in?
So the second segment is
Okay. There it is. So r, how do I find r? So the square root of 5 squared plus 6 squared, which is what? Okay. Now I need theta, so we're going to use this reference triangle to figure out what theta is, right? Chase said we need to use the tangent. The tangent of theta equals what? Right? That's over 5 up 6. We're going to do 6 over 5. It actually does not matter if you put the negative in there or not because we're working with a reference angle at this point. Okay? So, what is the angle when tangent is 6/5? Okay. So if our reference angle is 50.2 degrees, we're working with a number in the second quadrant. What is that angle of rotation? What? 129.8. Okay. So, our number, -5 plus 6i, is the same thing as the square root of 61 cosine of 129.8 degrees plus I times the square root of 61 sine of 129.8 degrees. Wow, I ran out of room. I apologize. Okay? Yeah, just so it doesn't get confused with that angle. Okay? Now you will also see this written maybe as the square root of 61 times the quantity cosine of 129.8 degrees plus I sine of 128.8 degrees. Okay, you may also see it like that since both of them have the R. Well, when I'm asking for trigonometric form, I want it with the cosine and sine. Okay, now to go back to standard form, then that's when you would solve that out. Okay. Which leads us to our next example. Okay. Here I have a complex number and it's given in trigonometric form. I want it in standard form. Okay. Now this is nice because 315 degrees, that's a nice angle for us to evaluate, isn't it? Yes, yes it is. Okay. So, what is the cosine of 315 degrees? Positive or negative? Positive, cosine in the fourth quadrant, right? And then, what's the sine of 315? So in standard form, our number is 3 radical 2 over 2 minus radical 2 over 2i. The I can come last when we're in standard form, like usual, okay? Not always, no. And at that point, you would approximate if there's not a nice angle. Oh, because, I messed up, I apologize. Thank you for catching that. Okay, that 3 does need to be multiplied through. So don't make that mistake. Alright. Questions on either one of these again? Okay. Now, I do want to talk about a shorthand of writing these numbers. Okay? Do you agree that this is a lot to write out? Yes. Okay. So this number right here, the shorthand for trig complex numbers would be 3 CIS 315 degrees. That is the shorthand. Okay. If you have a trig complex number, you can write it as R CIS theta, and then you don't have to write it all out. That is an option. So when you see this, it just means this expansion up here. Okay, so the CIS, the cosine, imaginary sine, theta. Okay, it's just a shorthand version of it. You don't have to write it like this, but you need to recognize what it means because I may give you problems with this with me. All right. So we're going to talk about two operations today with complex numbers, and then we're going to talk about another operation tomorrow. Okay. On your blue sheet last night, you guys had to multiply some complex numbers. How did you do that? Thank you. How'd you do it? You had A plus BI, A plus BI. Foiled, okay? You foiled, right?
Yep.
And then you had to simplify because you probably had a nice square in there somewhere, right? Okay. Did you have to divide on that homework? No. Okay. Do you remember dividing? Where you had to multiply by the conjugate in the denominator? Okay. Now, but with trig complex numbers, we have an alternative way to multiply and divide. Okay? So here are our two complex numbers. Complex number 1, complex number 2. Okay? So if your complex number is in trig form, then to multiply the two of them together, all you have to do is multiply the r's and add the angles together. How do you think division is going to go?
Minus.
Divide the r's, subtract the angles. So I'm going to move this up. Now, I do need to make a little note. Your angle needs to be between 0 and 360 if we're working in degrees. 0 and 2 pi if we're working in radians. Okay? It's not typically a problem with the product. Well, actually, yeah, that is a problem. If you get an angle that's above 360, okay, or here if you get an angle that's negative, you need to find the coterminal angle where we would be between 0 and 360. Does everyone have these copied down? Okay. So here we go. First one, I have a product of these two complex numbers. Notice how they are in the shorthand version. Okay. Okay. What? Oh. Okay. So we're multiplying, which means we take our r's and do what with it? With them. We multiply them, so 4 times 6 is 24. And then what are we going to do with our angles? We're going to add them. So what is 120 plus 315? But it's over 360. Okay, so what's the coterminal angle for 435? First of all, how do you find it? Subtracts 360, so what is that? And that's your answer. Okay. Okay, now I have a division problem. Okay. What do we do with our r's in this case? We divide them. 15 divided by 3 is? And what do we do with our angles? Subtract. What is 240 minus 135? What? And that angle's between 0 and 360. So we are okay. Any questions? Here is your homework. Okay, I want you to turn to this page. I want to point something out. Okay, from 47 to 57, they give you the number in trigonometric form, and you multiply or divide and keep it in trigonometric form. Okay. Now in 59, 61, and 63, they ask you to write the two numbers in trigonometric form, then do the operation and put it back to standard form. Okay? And they also want you to do the operation in standard form. Okay, so they want you to do both ways so you can kind of feel out, okay, which one is easier, which one's more. Okay? Any questions?